Hello friends, this is Shivam and welcome to my YouTube channel. So this is another video in PySpark, and today in this video we are going to check out two main functionalities of PySpark, that is transformation and actions. So what are transformations? Transformations are like lazy operations on an RDD that create one or more new RDDs. Okay, each RDD is a dependency chain, or like a string of dependencies, and has a function for calculating its data and a pointer to its parent RDD. So most probably, what is a transformation is it is used to transform one data set to another. Like say you have x equal to 1, and then you transform it to string, like y is equal to str of x. So this is a transform operation that you are doing. Okay, just as an example, there are different transformation operations that you can see in the screen: map, flat map, filter, group by key, and all. And also you can see actions. And what are actions? Actions are like, unlike transformations, they produce RDDs. Actions functions produce a value back to the Spark driver program. Actions may trigger a previously constructed lazy RDD to be executed. And few examples of actions are like, you can find out sum, you can find out mean, variance. Then these are the, you can, in the screen you can see reduce, take, count, collect, and all those things. So we'll be seeing all this in the code, and let's jump back to it. Okay, so here is where we will be coding. It's a Jupyter notebook here. Okay, and okay, so this is just loading the dependencies and all. This is first we have to create the the Spark config. That is a conf object is the configuration of the Spark application. Here you have to give the app name and the master URL. This is the local we are using in the local system, so you are giving it. And after setting the Spark context, we'll just 1 minute. Okay, so it is already running. Okay, see, you cannot run re multiple contexts at once. So since I was already running it, so you cannot do it again. You have to restart the kernel and do it again. Okay, so most probably we will go with the previous Spark context as well. So this is sc.parallelize. This is used for creating RDDs. Okay, this is a list you are passing to sc.parallelize. This sc is the Spark context. So sc.parallelize, and this values is a list. So it creates this, and this is the action. Okay, this take is the action, as you have seen in the presentation before. This take is used to print. There are two functions to print the values, that is take and collect. In take you have to put a number inside, so that because if you don't put a number it will not work, because you see it is asking for missing one required positional argument num. So you can put like all the values till 5, because we have 5 values here. You can put less values as well, how many values you want to print. So RDD or collect also does the same thing. It will print out all the values. Okay, so we have like a spark.txt file here for example, and it contains this only one text. Okay, Apache Spark with Python is PySpark, is nothing. Okay, this is the spark.txt that we have got. This is a text file. So if you do that, if you load it using sc.text file, that is a spark.txt, you can give the path if it is in another folder. Okay, then you do a rdd.collect. Using this you can print the content of the text file. After that, this is nothing. This is just the RDD persistence. What is persistence, what is caching? We have to know that first. Okay, so what is persistence? Persistence is like Spark's RDDs are lazily evaluated, right? Thus when we wish to use the same RDDs multiple times, it results in recomputing the RDD. To avoid computing an RDD multiple times, we can ask the Spark to persist the data. So in this case, the node that computes the RDD stores its partition. Okay, so you can see this Python RDD 6. So after this, if you do that aba.persist, then we can see this. Okay, that it is the node that computes the RDD stores its partition. So you can just print the contents like 1 to 10,000 and with a gap of 2, okay, with a jump of 2. So we can see 1 3 5 7 and all. You can print more values if you want, because you are having values till 10,000, you can print anything. So it will have a difference of 2 because you are putting a jump of 2 here, okay. Okay, so next is caching. So RDD caching. So what is RDD caching is all about, okay. So caching is very useful when data is like accessed repeatedly, okay, such as querying a small hot data set or running on like iterative algorithm. uh, so we use caching because it is fault tolerant also. So it's just simple thing like a text file dot che, okay, to do the caching. So this is it. So let's jump up to the like transformations that you've seen on the screen before, like on the presentation. So these are the some functions like map, filter, union, intersections. So we'll go one by one. So what is map? So using map you can you can map as you, if you have used pandas before, you have already mapped one data type to another. You have mapped like you have, if you have a int data type, you can map it to string, you can map it to different data types, okay. Then using lambda functions you can create these you can create tuples, you can modify the data as you want, right. So here we have like a list of strings, and just we are doing x and x comma 1. This x will be the, you're iterating over the list, okay, here. So x dot map, so x is the RDD, the sc dot parallelized form of this list, and you are creating just you're giving the value of 1 to each string here. So you will find this list of tuples here with each pairs formed key and value. The value will be 1 for all because we have set it to 1 here. As per your requirements you can do any functions, just an example. Okay, using filter operations you can filter out anything that you want from a list, extensively used in like in exploratory data analysis. If you are doing like machine learning task, for data analysts also is very useful. Like if you want to filter out, this is a simple example where I filtered out the even elements from this list. So 2 4 6 8 12, see here x modulus to equal to 0, and dot collect for collecting, like for printing out, okay. So this is the union operation where every one of you, I think you know what is union is. It gives you the combined value of see, from a it is range between 1 to 9, and b it will range between 5 to 15. So here we can see that there in union, if there is no distinct element, so you will get all the elements, okay. So there is it is not a set operation that you are doing here. So you are doing here see 1 to 9 you will get here, 1 to 8, and then in different form you will get here, okay. Then 5 to 15 here. So I think there is one less in range, actually it is n minus, it will go till n minus 1 in Python, okay. So it is, you are getting from 1 to 8, then 5 to 14. Great. Next part is the intersection part here, okay. In intersection you can see that you will get the common elements between the two, and here 1 to 9 and 5 to 15, so the common elements will be 6 to 7 here, okay. Okay, so the no, 6, not 6 to 7, actually it is 5 6 7 8, yeah. And in distinct operation here you can see that you get all the distinct elements. If you want to collect all the distinct elements by union, see here you're doing a union, and then you are doing the distinct and dot collect to get all the files, all the data, okay. This is a distinct operation, will give you the distinct records. This is a sort by. Here you have to just put a false and a true here. This is the true for ascending and false for descending. So as you can see I have given a false here, so it is giving you here a descending, like a descending output here, okay. So if you just convert this to true, it will probably give you 1 1 2 3 4, okay, see, as the output. So it is giving in ascending order. Next, you can do this using keys also in dictionaries, okay. In tuples you have to find, you have to provide a list of tuples here, okay. And in this one what you are doing is here there is a true and false thing, okay. This is a sort by operation you are doing. So it sorts it using the keys. Okay, so here you're given false, so false for descending. So you can see that Z is more ASCII value than H and then A. Okay, so you can do true here, and you can see that it will be A, H and Z, because it will sort using the keys. Okay, so this is just a simple group by operation. In group by, here what we are doing is we are grouping it, like you are giving a even, it will create two groups here, because one group will be created with all the even values here. Okay, and if you have the even value, then it will give a value of true, and then it will give you a list here. Okay, because you're doing this X is the true or false you're getting here, and this sorted Y is the value that the groups that you have formed. So out of this you can see a true value with the even numbers 2 and 8 from this list, and all the others we have sorted the values here. You'll get like a false because it is not putting the condition that you have given here. So it is false here, and you get the odd numbers here. Okay, so this is zip, used to form, extensively used to in dictionaries and to form couples or pairs. Okay, so here you can see A is ranging from 1 to 5, B is ranging from 1001 to 1005, and then you do A dot zip B and dot collect to print. So it will just zip it using, see, one, it will map 1 to 1 here. So 1 and 1001, 2 and 1002, and till 5, till 4 and 1004, because until n minus 1 this range goes. Okay, till Python. Okay, till 5 if you want to go, then you can probably do 6 here. Okay, oh sorry, because yeah, everyone knows that one will be less because you're zipping it. Yeah, see, you're getting it. Okay, okay, so this is the repartition. So in this, what you're doing is, it is called RDD partitioning. Okay, so Spark actually manages data using partitions that help parallelize distributed data processing with like a minimal network traffic for sending data between the executors. um, by default, the Spark tries to read data into RDD from the nodes that are close to it. Okay, and the RDDs get partitioned automatically without the programmer's intervention. Like yeah, automatically it will get partitioned, and you will see in the examples later. Okay, yeah, I'll show you how it gets automatically. It will get partitions. There are different types of partitions. Actually, there are like um, hash partitioning, there is range partitioning. In hash partitioning, what happens is a hash key is used to distribute the elements across the different platforms, and in range partitioning, the keys in this are partitioned based on the set of sorted range of keys and ordering of the keys, something like that. So here what we are doing is, we are going to create a RDD, and we are like doing a partition of 4. So like you can specify how many partitions you want. We are doing a partition of 4 into this list. Okay, so if you do a dot collect, you will not get it, because we have to use glom function here. And what is glom? Glom transforms each partition into a tuple, immutable list of elements. It creates a RDD of tuples, one tuple per partition. So if you just uncomment, comment this one and uncomment this, see here you are getting 4 partitions. Okay, 1 2 3 4 5 6 7. So if you want to give 3 partitions, then obviously you will get 3 partitions here. Okay, see, 1 2 3 4 5 6 7. So automatically Spark handles this partitioning inside. Okay, so here you can see that we have given till 8 here in the list, and did a partition of 4, so equal partitions 1 2 3 4 5 6 7 8. Okay, this is the coalesce operation. This is used to reduce the number of partitions in RDD. So if you see, we have taken an example of ACID parallelize here, and doing a 3 partition here. Okay, dot glom and dot collect is to print it, like you have seen this part. Okay, okay, and this is the coalesce function. Here what we are saying is coalesce of 2. So coalesce of 2 means we are reducing it to 2 partitions. Okay, we are already doing a 3 partition here, and then we are reducing into 2 partition. So here you can see that it has reduced it to 2 partitions. In 3 partitions you will get this result. In 2 partitions it has just done automatically. So if you do a 3 partition again, so you're doing a 3 partition and then again you're coalescing into 3 partitions, so you're doing nothing. So you'll get the same result as you have got, see, in while you have tested this thing out before. So these were the few transformations which are extensively used in Spark and PySpark. Let's also look into actions, which are things like reduce. So what reduce operation is doing it, you are just importing some operator, that is a multiply, add or something, and you are doing a SQL parallelize, you have to pass the list and do reduce add, so it is giving you the sum of all the elements in this list. If you do a mul here, that is, it is multiplying it. Okay, so you're getting all the multiplication of all the digits here. Then this is the first. So what is first is you're getting the first element in the list. So 10 is the first element, you are getting the first 10 as an answer. Take, you have already seen, it is used to collect the elements from this list and print it. Okay, take and collect, the same thing. If you want to print only 4 elements out of 8, you can do that as well. Okay, you get the first 4 elements. Take ordered. So what is take ordered? Take ordered, it will give you a like ascending order list here. Okay, it will order the list for your convention. So you can see that it is 3 4 6 8 in ascending order. Here you can specify if you want to view it till 5 or view it till 8 or anything. Okay, you can give the range here. Okay, so extensively used in data analysis part. Okay, count. Count, it will give you the number of elements in the list. So here 8 elements, you're getting 8. Okay, this is collect. You have seen before, take and collect. Okay, they are used to collect the elements from the list, from the RDDs. AC.parallelize uses RD, you are collecting it from there and you are showing it. Okay, so here you have 2 examples. As we have done distinct here, you're not getting both, you're getting one. Okay, you're getting the distinct elements. Okay, and here are some like mathematical operations like that you can perform, the sum, max, mean, variance, standard deviation out of this the elements that you have provided in the list. Okay, these are the operations that are going on in the RDDs that you have created using AC.parallelize. This is the count by value. So what happens is you can see that how many times you can get the frequency here. You're using the count by value. It is you can say it is same as a function in collections. There is a counter function. So you can use that, or you can use this also, count by value. So you can see that you have occurrence of 10 is 3 in this list. Okay, 1 2 and 3. So you can see that 3. So 10 occurs 3 times, 50 occurs 2 times, and like this we'll get the dictionary key value pair. Okay, so this is the creating paired RDDs, and I'm sorry. So here we can see that we are providing tuples, 2 tuples, list of tuples, and creating an RDD, and we want to we are just printing it using this. Okay, RDD.map, you're mapping it. Like map function is used as per your needs, like what you want to do and all. So x0 and x, the remaining part from 1 to, this is the x0 part. Okay, and this is 1 to the rest of the part. Okay, there is no till there is no end position, till it will take it to the end of the list or tuple you have given. Okay, so b1 c1 d1, and here in case this is the x0 and this is the rest of the part. Okay, so a2 is the x0 part and this part is this part. Okay, the rest of the part. So this is what you are creating paired RDDs, and this is reduced by key. So in reduce by key, what you're doing is you can see here that you're doing a reduce operation, that you are doing a multiplication or add, that does not matter. So here we are doing an add operation, and how will you do the add operation? The it adds values when the same key is found. Okay, so here the key is 1, here the key is 3, here the key is 3. So these two are having the same keys. Okay, so it will add the values having the same keys. So it will give you 3 comma, you will get 4 plus 6, that is 10 here. okay, and there is nothing for 1. If we put an example here, okay, so if 1 comma 6, so if you run this, you can see 1 comma 8 and 3 comma 10, because 6 plus 2 is 8. Okay, so this is what, and there is a lineage graph. Okay, so what is a lineage graph? So RDD lineage is a graph of all the parent RDDs of an RDD. It is actually built by like applying transformations to the RDD and creating a logical execution plan. Simply you have to do this RDD dot debug string to get the lineage graph. Actually, it is a series of transformation that you have already done. As you can see here, that you're using a filter, you're doing parallelize, you're doing union, you're doing sort operation. So these are the operations that you can see in this graph. Okay, see here, you can see this is the pairwise at sort. You're doing sorting. Then you can see, just give me a minute, we can find it out here, that we are doing union here, you can see. Okay, so in this operation you will find out, you will get a lineage graph of like all the parent RDDs, whatever the operations that you have performed here. Okay, so that's it for this video. If you like this video, please like and subscribe to my channel, because next video we can take up some real world use case on machine learning using PySpark. Okay, we will be solving regression problems, you will be solving multi-class classification problem. If you want binary classification, that is just just downgrade the multi-class. So we'll see all those, and one by one we will also see like how to handle the text features, how to handle the numerical features, and how to handle the categorical features in PySpark. So we all are mostly familiar to pandas. Working in pandas is obviously very easy. We'll also look in like how we can use the Spark data frame, and we can work using PySpark. Okay, it is little difficult, but practice makes a man perfect. So that's all. Thank you, and please subscribe to my channel. Bye bye.